LMTD or log mean temperature difference is very easy when we know the inlet and outlet temperatures of cold and hot streams. So LMTD is easy method. Either we know the inlet outlet temperatures of cold and hot stream, or they can be easily defined or determined from energy balance. So when we have that one, then we can easily use this LMTD by knowing delta T LM as we defined before, and mass flow rates for the hot and cold stream, and the overall heat transfer coefficient mu U. Then we can define the amount of or determine the surface area by Q is UA delta T LM. So by knowing any of these parameters, we can get the other one. Generally speaking, this LMTD generally we use LMTD method is very suitable for sizing of heat exchangers. So we can determine the size of heat exchanger to satisfy the prescribed inlet outlet temperatures, mass flow rates of hot and cold stream. There is a procedure that we use generally, like for different problems. Procedures for determining the size of heat exchanger using LMTD. I'm just going to list the steps that we generally take. First of all, we select the type of heat exchanger. Whether it's going to be easy double pipe, shell and tube, the multi-pass shell and tube, or it can be the parallel flow, counter current flow, and different things. So we select the type of heat exchanger that is suitable for the application. Whether we have a stream of two liquids, or we have a stream of, let's say, hot gas, and then another one is a liquid. And depends on that, we select the type of heat exchanger that we want to work. Then we determine any unknown inlet and outlet temperature using energy balance. So we get the inlet outlet temperature using energy balance. The next step is we calculate the log mean temperature difference as a driving force for the heat transfer. Then if we don't know, we calculate convective heat transfer coefficients. I'm just going to call it HI and HO, referring that, let's say, to the flow that is inside the tube and outside the tube. And so far, we have seen a lot of correlations for the forced convection, and we will see for other type of convection later on. But then we define this convective heat transfer, and then we calculate or determine the overall heat transfer coefficient. coefficient or U. Then having that one, we can calculate the surface area. Remember, Q is U. This is going to be the surface area required for the exchanger delta T LM. So we determine the surface area. Now, based on that, we select, based on the surface area, we select a heat exchanger that has a heat transfer surface area equal or larger than A. Enter that. Larger than A, and up to here our task is done. Then all goes back to the economics, whether the heat exchanger that we have, we can afford having that one. Another problem that can arise, or another situation I would say, is, let's say we have a heat exchanger in storage and you've been asked whether to determine whether it can do the job for the process. Let's say you're gonna heat it up, like the oil that's going from one to another one, or cooling down of the oil, or heating up the water, or the other things. So what you would need to do, so let's say we have a heat exchanger in storage and we want to know whether will it do the job that we are looking for. So for these type of problems, generally what we know is, we typically know the mass flow rate. So we generally know m dot C and m dot H, the mass flow rate for the cold and hot streams. And we know the inlet temperature. We know, let's say, Ti, Th, and I, and Tc and I. So this is mass flow rates for both streams, and this is the inlet temperatures. Temperatures for, again, cold and hot streams. Now our job would be first to determine the rate of heat transfer and the outlet temperature to complete and make a recommendations based on that one. And so we generally know we need to find Q and Tc out, the cold stream out, and Th out. So these are the unknowns that we have. Still, we can use LMTD method. LMTD method can be used, but it requires a tedious iterations, which is not really practical. But requires iterations, and that's really not practical. So we go for another approach, and another alternative method to LMTD was introduced by Case and London in 1955, calling effectiveness NTU method, that I will discuss very soon.